Hey everyone, we are coming live again from our Tyson's Corner office. Mykel is already on the channel. He's going to be live with us doing his presentation in just about 5 minutes here. Just a quick recap of this morning. We had a great kickoff this morning with Larry Maccheroni from Comcast. If you didn't see that session, really super session where Larry, of the number of things that he presented, talked about the kind of DevSecOps self-assessment that his organization uses at Comcast to kind of score where they are within their organization, where they need to do improvement, how they want to prioritize improvements. So definitely check out that session. That was followed up with Brian Fox, who did some a number of different points in his conversation, but the one that really struck me and I put in the Slack channel was his timeline for how open source components are being utilized by the hacker community to do crypto mining, and also the issues with typo squatting. So a fascinating conversation there as Brian kind of walked through that timeline of what the open source ecosystem, not only Java, but JavaScript, the Python community, the NuGet community, Ruby community, etc., have to be aware of as they manage these large central repositories of open source components and the volumes that are being consumed there. So really great conversation there. Also, the one that we just concluded with Matt Howard, our CMO here at Sonatype, interviewing Wayne Jackson, our CEO. Fascinating conversation from people that, one, are running the business, two, have been in the business for quite some time, and just seeing the evolution of kind of what happened in the industry. Some of the moves and investments that we made early on at Sonatype to be in the right place in the right time, the investments that we made in certain technologies. But also, areas like all different companies that are, earlier in their evolution, you get lucky sometimes, and you're in the right place at the right time. You meet the right people, and that helps to continue to evolve the business. And as I said in this morning's kickoff, we continue to evolve and grow, which is really exciting here at Sonatype, as we've been growing our user base 92% in the last year. Huge growth trajectory that we continue to see there. So this afternoon's sessions are no less exciting. As I mentioned, Mykel Prescott is going to be live on air with us in just a moment here. But looking through my agenda, Stefan Simenon from ABN AMRO, I just met him a couple of weeks ago when I was in Amsterdam, talking about their DevSecOps journey there, is going to be coming up. Hiep Tran from Capital Group, talking about how they're applying DevSecOps practices across 1,000 applications in their portfolio, is going to be super interesting. Our friend Michael Alvis at Cotiviti, super knowledgeable guy and a great presenter. So I haven't seen his latest presentation. I'm looking forward to seeing that. Because he's always, tries to be a little controversial in his approach there and his advice. So definitely looking forward to hearing him and chatting with him on Slack as well. Then we're going to follow up with Jamie Whitehouse from Sonatype, who's the product owner for Nexus Lifecycle. DJ Schleen, who I've seen present a number of times, fascinating to tell the DevSecOps journey at Aetna. Sarah Elkins, who's at General Dynamics IT, working with the National Institutes of Health on their CI/CD platform with Nexus. And then we're going to conclude this particular track with Jim Bird, who is the CTO over at BIDS Training, or BIDS Trading. He wrote the book on DevSecOps for O'Reilly. If you haven't read that yet, it is available online. So very exciting to see the track that we have in store. We have a later afternoon track that we'll also go live on. But with that, it is 10:45. Mykel, are you on? Can you unmute yourself and join us?
I am on, Derek.
Okay, excellent. So I now have you focused on the core presenter here, and if you have slides to share, if you can bring those up, I can hear you. So that's first part of the battle here always, and I see your slides. So that's the second part of the battle. So without further ado, Mykel Prescott is going to tell us a little bit about what we don't know about the Nexus repository, perhaps that 80% of features and Nexus repository that that some of you don't yet use and some of our power users are using. So Mykel, take it away.
Thanks, Derek. Actually, I have a slightly different spin on this. I'm going to talk about recent history and recent features. There's a lot of things that has happened both internally to the team and in terms of the feature sets that people don't know. And that's what I'm really covering now. So as Derek said, I'm Mykel Prescott. I'm the product owner for Nexus Repository 3. You probably learned you've probably learned this about us by now, that all the engineering team across all of Sonatype is fully remote. There's no two engineers in the same place. And I guess they decided sunny Toronto, Canada was a good place to get the product owner. I've been at Sonatype since April 2014. I've been the product owner of Nexus Repo for about half that time. If you want to reach out to me, you can do that using Twitter at devcasing. And I'm going to talk a little bit at the end about how you get in touch with me and the team in a whole bunch of other different ways as well. Okay, so in case you were told to attend this talk, first of all, I'm really sorry, but just to catch you up, Nexus Repo is a parts warehouse for all of your software components. In fact, it is the world's leading repository manager. We've got first-class support for a whole bunch of formats, including your favorites like Maven 2, Docker, NuGet Yum, Ruby Gems. We've got support for raw repositories, which lets you do all sorts of different things. But also we have a burgeoning community. I think I looked a few days ago and we were up to 48 community projects relating to either Nexus repository itself or other things at Sonatype. Head over to exchange.sonatype.com and Jeffrey Hesse will get you set up. Tell him that I sent you there. Among those offerings, we've got community supplied plugins for other formats that are popular. So we've got apt, P2, R, Helm, CPAN, and Conan. So what I wanted to talk about today, though, is about a kind of conversation that I end up having with users and customers of Nexus Pro. And it goes something like this. It's, someone will be saying to me, look, we really love our Nexus repo. We love the features that it has, but if only it could do this one other thing, we'd be really happy about that. And my reply is often something along the lines of, yeah, we actually shipped that a few versions ago. Which leads me to sad Kermit feelings because, a feature that nobody knows about isn't delivering any value to anybody. So clearly we need to do a better job of talking about the kinds of features that have been put in the application for your use. Why do we have this problem? I mean, maybe we're following the old writer's advice of show, don't tell, which is probably good for writers, novelists, and hobbyist screenplay writers, but maybe not good for an application development team with a globally used application. But I think the other reason is that we are accelerating development with Nexus Repository 3. The pace has picked up substantially, and there's actually a lot of new features that have been built in that people just don't know about yet. Okay, so a little bit of history. Nexus Repo 3, we had a first version of, first public milestone of 3 in January 2016, so just over 2.5 years ago. That was milestone 7. It was the end of a long development period of a new architecture for Nexus Repository. We did that because we wanted to have first-class support for a whole bunch of different software ecosystems. That was really important to us to be able to implement new ecosystems quickly, to be able to roll out features across a whole bunch of different formats and ecosystems without having big disparities as we had done with Nexus Repository 2. Now, Repo 2 is a solid product. It's still in use at scale. But the implementations of other formats like Yum and NPM, those don't fit naturally into into a Maven-centric architecture. And Nexus Repo 3 really was an opportunity for us to do a ground-up implementation that made it really, really easy for us to deliver features to a whole bunch of different ecosystems all at once. So when we shipped that, it had 5 formats: Maven, Raw, NuGet, NPM, which we'd had before, and also a new format, Docker. Over 2016, we started a bunch of big efforts. So we started the development of high availability clustering, which I'll talk a little bit about later. But we also shipped new formats, Bower, PyPy, Ruby Gems. We did a lot of performance and scalability work. We made it so that it was easy to migrate between 2 and 3. And we added support for firewall, which I'll also, again, talk a little bit about later. Across the beginning of the first half of 2017, we added another format, Git LFS. We did yet more performance and scalability work. One of the things that happens with 2, with its long history, is that we've been able to grow organically. As new users come onto 3, people are saying things like, I've got 5 terabytes. I want to migrate straight into that right away. And we've got to be ready to go 0 to 60 with those customers at the scale that they're already at very, very quickly. So we've put a lot of effort into that. We had a new format. We started development on Yum with Yum Proxy, and then we shipped a GA version of the high availability clusters. Okay, and what we found is that as we've entered those new ecosystems, our user activity has gone tremendously up. We're literally into millions of users now. So one of the things that this does is, as we have more users, we have more use cases. We have more components, more types of components, not just different formats from different ecosystems, but also just a sheer variety of things that people are doing with existing formats. We have to adapt to more situations. We get way more requests from a diversity of users, and as I said, at ever higher scales. I happen to know that there's a Nexus Repository 3 instance out there that's serving over 25 million requests per day as part of a farm that's handling 1 billion requests per month. So we're definitely there at scale. Okay, so that's the stuff you can see from the outside. I want to talk a little bit about what's going on inside the team, what's going on developmentally. And I want to do that from a slightly personal perspective. So I'm going to jump back 4.5 years, I guess, to April 2014. This is the first engineering meetup that I attended. Literally, it was my first week at Sonatype. And the format for this was, as I said, we're all remote, so it's really important for us to get together to meet our coworkers. And in my case, it was a fantastic opportunity to do that while I was still so new. There I am in the top row with the black t-shirt with a little crest on it. And the format for this meetup was everybody was going to present something to everybody else at the engineering team. Now, I have to say, I was a little starstruck by the caliber of people that I was working with. Suddenly, I was used to being a big fish in a small pond, and now I could literally turn to anybody in this organization and learn 5 jaw-dropping technical things from anyone I could turn to. So when they said we'd like everybody to present something that nobody else knows, that's really going to, give them a unique perspective, I was more than a little nervous about the caliber. So what I turned to was something called sociometry. It's a tool. It's actually analog social network analysis from the dark ages, before we even had anything called social networks. It's a tool for finding your place, and that requires information. So it's a face-to-face social exercise. Now, I'm not going to talk about sociometry a lot, but one of the things that it allowed me to do is really keep tabs on the size of the engineering organization, because this exercise was very successful. We revisit it each year, and so I've been wrangling an ever larger crowd through this exercise at the beginning of our meetups. So here you go. A few years later, look at the size of the engineering team. And we can't always, all of us make it. There's Daniel Sobel, who you'll hear from a little later, attending remotely, like a little R2D2 unit. But we keep growing. Here's us making a map of all the different parts of the world that the engineering organization comes from. And here we are, all lined up by tenure. So if you squint and really lean into your monitor, you might be able to see against the presentation board on the right-hand side, a little tiny Brian Fox there as employee number 1 of the engineering organization. So obviously, that is not all of the Nexus Repository team. We have a bunch of different products, a bunch of different operations and data teams here. But this is proportional to the amount of investment that we're making in the Nexus Repository team. In April 2014, when I started, we had 1 team of generalists. In June 2018, we have 4 teams, 4 specialized teams, all contributing to Nexus Repository in different ways. Okay, one of the things that we've done with that increased investment is accelerate the release cadence. So you can see back in early 2014, we're hitting 70 days, 65 days between releases. This is a rolling average. Now we're averaging more like 25 or 30 days between releases. This is a substantial increase in the frequency of releases. So one of the things, we hate shelfware. We don't like writing functionality that nobody can actually benefit from. So we're releasing more frequently to get the software into your hands faster. Now, of course, we know not everybody can update to every version. It doesn't make sense for an organization perhaps to update every single one, but we know that somebody can benefit from every version, which is why we're committed to doing this. Okay, not only are we releasing faster, but we are releasing more. This is a slide out of our Jira. I've changed the colors. Blue represents all of the issues, bugs, stories, features, improvements that we've implemented. That thin green wedge, which you can see steadily thickening, I hope, if you maybe squint at the slide, is the in-progress work, and the orange is the ever-growing pile of things we want to get to. And but what I want to draw your attention to is the rate at which that development speed is increasing. So if you look at these inflection points, there's a couple of pronounced ones in 2015 and then in the early 2016, and maybe that last one's a little bit of product owner optimism, but it definitely mirrors our subjective experience that we are releasing software significantly faster and new features are coming out. So we've built a lot of things. We're still accelerating. So it isn't surprising to me, really, if you've missed hearing about a couple things that I want to go over and hit the highlights. So one of those is UI upload. So this was a much requested feature. It was very popular in Nexus Repo 2. It is a way to take components that you've got from perhaps a third-party vendor or that were produced with some offline process or air-gapped perhaps, and upload them manually one at a time. You can choose the coordinates. If you're using Maven, it will generate a synthetic POM. If you are using other component formats, then it will generate all the appropriate metadata for that, so you can seamlessly use it in search and all the other features. And it integrates with our tagging feature. I'm going to come back to that. Okay, blob stores. So you may or may not know, internally Nexus Repository 3 stores two different kinds of information about your components. It holds metadata in a metadata database. So that's all the information about coordinates, about deployment time, who deployed it, all the audit information, but it also holds the binaries themselves. Of course, those are stored in a object store-like system on the file system, but we've added support for using S3 as the backing storage for those binaries. That was also much requested. This has a powerful affinity with any AWS-based deployments, especially HA clusters, because you can use it as a shared file store between that cluster. This actually started life as a community implementation. So I'd like to thank Andrew Taylor for getting that started. We also have community implication. Implications. What's the implication of stumbling on that word? Implementations for other object storage, such as Google Cloud Object Storage. So if you're interested in that, go again to the community, tell Jeffrey I sent you, and check that out. Okay, I'm going to shift gear a little bit. So you may not know this, and if you have been a diehard repo customer and not exposed to our other offerings, this may surprise you, but Sonatype produces the world's most comprehensive and accurate database of OS vulnerability and license information for open source components. We have an offering called Firewall, which will allow you to stop those components ever entering your software development lifecycle. It is a fantastic way to get into some of the value add offerings we have. Formerly, this was only available as an add-on to Nexus Repository Pro, but we know that if you don't happen to need the pro features of Nexus Repo, you can now benefit from snapping a firewall on and getting the benefit of all the information we have about these open source ecosystems. Okay, REST. Everybody asks about REST. When will REST be done? When will you have this feature? One of the things we wanted to do is add a console inside Nexus Repo to make it as easy as possible for people to get up-to-date information about what we support, to learn it and play with it. So the Swagger API is built right into Nexus Repository. You can see there on the navigation, click the API option, and you will get a console. It's an interactive console that will allow you to see all of our endpoints. And we have a lot of endpoints now. We have endpoints for content, for searching, for managing your HA clusters, all sorts of provisioning tasks that you might want to do, setting up repositories, users, monitoring and setting up scheduled tasks, and for the staging and tagging features that I'm going to talk about a little bit later. So this console lets you learn what we have. It lets you actually try them out interactively. Once you've done that, you can take those commands. It will generate curl commands for you that you can then copy and paste and use in your scripting. For your provisioning or whatever kind of administration you're doing from a command line perspective. And you can even use the extended Swagger toolchain to generate clients to make it really easy to automatically control your Nexus Repo instances. Okay, so tree view. When we implemented multiple format support as a first-class citizen, we decided that because a lot of formats were not hierarchical, the best way to browse all of the content was through a search-based paradigm. Turns out, well, everybody loves tree view. So we've brought tree view back, the much requested feature. It is a natural and popular way to explore hierarchical content. Not all formats are hierarchical. So, maybe browsing your Docker layers and your Git LFS objects is not naturally done through a tree view, but for others, it is actually a handy way to get in there and start administering, checking your metadata and audit information. There's also an HTML view. There's a little view up there in the top left that links to an HTML view you can use. It brings back a popular feature from Nexus Repo 2. Please don't scrape that. We've got REST endpoints for that now, but if you want to use that, go ahead and do that. Okay, Yum. I mentioned that we started on Yum proxy. This is a completely ground up reimplementation of Yum. It was a popular format in Nexus Repo 2, but we needed to make it perform better. So we've got now proxy hosted and group support. And we've been through a second round of performance enhancements to metadata generation to really help this work at scale. High availability clusters. So Nexus 3 is a rock solid application. If you've got a single node and you're administering that, you'll know that. But if you need to go that last mile and you need to support high availability, you can do that when in conjunction with your load balancing system and some kind of shared blob storage, for which S3 is a perfect choice now, especially if you're deploying into Amazon. You can set up a cluster of Nexus nodes, Nexus Repo nodes. They'll communicate with one another. They'll share and vote on component metadata and allow you to get that extra few points of availability out of your Nexus deployment. Now, here's a fun one, staging. This is a newer feature. So if you are using Nexus Repo, you're at scale, you've got a whole bunch of teams piling content in, and I'm just representing that here with teams A and B. But you might have 20 teams or more. You've got an issue that's accumulating. You've got new untested and approved components all mixed into the same hosted repository. So what that does is exposes you to a particular kind of problem, which is that your QA and UAT users might be picking up components that are not really ready. They're not really signed off or ready for those UAT processes. You might even have production deployment systems that could inadvertently pick up components that have yet been through all those quality gateways. So what we've done is we've added a batch of staging features to help protect you from those situations. Okay, so the way this works, we've got REST endpoints, and it's based on a very simple but flexible and powerful search paradigm. So anything you can search for, you can then, through REST call, move and delete that around inside your Nexus repository. So we expect this to be orchestrated by your CI/CD tooling. That's a big difference from how we implemented things for staging in Nexus Repository 2. But it builds on the primitives that you already know for Nexus Repository security, and it's powered by tagging, which I'll cover in a second. It makes it very, very flexible. So what I'm about to show you is an archetypal staging workflow, but it's only an archetype. You can actually set this up a whole bunch of different ways. But in this example, you've got a team A development, and they're pushing their components into a hosted repository. These are untested components. When they're ready for UAT, either they or Jenkins or any other external orchestration system makes a single REST call, takes those components and puts them into another hosted repo called ready for UAT. You could call that whatever you like. Nexus Repo doesn't attach semantics to this. That's just all implied by the privileges that you've given various users. In this case, QA and UAT stakeholders can't pick up content from your untested components. They just can't see those yet. They're not made available. However, they can see everything in the ready for UAT. They can make REST calls. They can use their format clients to download that content and perform whatever automated or manual processes you have in that pipeline. When those gateways are passed, you can make another REST call and move things over to a production ready repo, some kind of prod, prod hosted repo. Now you've got your production ready stakeholders can see those things and not a moment before. So you've got production deployment systems and other teams that are using properly gated and vetted components as dependencies in their own development. Okay. One of the advantages of implementing staging the way we did is that it is very flexible for things that are not necessarily classic staging operations. So you can actually treat it as a generic move by Gav. You can find components, you can issue searches, and use that for generically administering your components and moving them around through REST calls. It also gives you a way to implement some custom cleanup operations, for example, scripting them externally by curl. If you can search for it, you can move it or delete it. And another thing that works really well with staging is having different cleanup policies by stage. So just going back to the slide, if you've got untested components that for some reason have not been promoted and made it through that quality gateway to be indicated ready for UAT, maybe you only want to keep those for 5 or 10 days, maybe 15. UAT components you might keep for a longer time. And production ready, that's going to, of course, be governed by whatever retention policies you have internally or regulatory requirements imposed externally. And you could move these things to a long-term storage in an archive repo with, backed by S3, potentially with a very different cleanup policy. So it allows you a lot of flexibility to implement your pipeline the way you need to. Okay, tagging. So here's a little cartoon repository with only 8 components in it. I'm just using this to illustrate tagging. So you can make a REST call, search for components, and apply a tag to them. Tags A, B, and C I've got here. The only requirement is that these are globally unique in all of repo. If you're using this for staging, these are going to be something like build IDs, maybe organization, project name, and then version. And you can apply these to arbitrary sets of components. It's very flexible. You can have overlapping sets. You can do single components. Components can have, tags can have thousands and thousands of components in them. You can have tags with a single component. And this works really well with staging. Because you can apply tags as you upload. We've added a new REST, or a series of REST endpoints, in fact, for a bunch of different formats, so that as you promote content into publish it into your Nexus repository, you can atomically add a tag. In most cases, that would be a build tag. But again, I mentioned this through manual upload. You can apply a tag right there. And then you can use that tag throughout the rest of your life cycle as implemented by that chain of hosted repos, or for any other purposes to kind of promote those, move those around, or delete them. So it's very, very powerful and flexible together. All right. Not only can you use tags in a flexible way, we've added the ability to add tag documents to these. So each tag has an optional user-supplied JSON document. You can add custom information to each component, to sets of components. There's one document per tag. You can put anything in there you like. I mean, it's limited to 20K. Please don't start base 64 encoding your Docker images and stuffing them in there. It's not a generic content management system, but for small amounts of metadata, it's the perfect way to annotate your components. You can link to external resources, for example, reports or database records held in other audit systems. You can put audit information about the build that produced those, for example, the versions of tooling, or who initiated it, or what node it was built on and when. You could put information about the quality gates that have been passed annotating those components directly. And some users have actually recorded downstream consumption information. For example, that this component was actually pushed to production on such and such a date. It's very flexible. Okay, that's the roll-up of features. I wanted to just hit the highlights that you may not have heard about or really fully had time to understand what the implications were for your organization. There is, of course, an endless tide of smaller improvements with our improved release cadence. Those come out regularly. They're too numerous to mention, but definitely keep tabs on the release notes to see if anything is relevant to you. But actually, so we don't have to wait until the next time we have one of these conferences to roll up features. There's a couple places you can stay in touch with us and understand what we're doing. One of them is right in your Nexus repo user interface. So this is the outreach content, and I think Daniel Sobel is going to be giving a talk a little bit later, and he's going to touch on some of the improvements that they've done here. They've put a lot of effort into trying making this useful for people. You can see an ad for this very conference here, but a lot of times you'll see information about new features, new versions that are available. You will also see surveys. So we will request information from you. If you are at all inclined to provide information to us, please engage with those surveys. We do use that to shape how we do feature development. There's also a bunch of other ways to keep up to date. So you can use the Nexus users mailing list. You can join the Nexus Pro announce mailing list if you're a Pro customer. And every time we do new feature development, we'll write a blog post. We put it up on blog.sonatype.com. So go there and subscribe. You'll get updates about Nexus Repo, but other products as well as interesting information from our CTO about the landscape of open source development. Okay, if you want to connect with us, specifically the Nexus Repo team, again, Nexus users is a great way to do that. If you've got questions, you might get help from other users. We also have a new community site, community.sonatype.com. If you don't want to use a mailing list, you'd rather use a site that's more fully featured, come on there, start topics, ask us questions. The development team is going to be engaging with people there. If you have feedback on a specific feature, you're using staging, you're using REST, and you want to give us feedback to shape the development of that, hit us up at nexusfeedback@sonatype.com. If it is not working for you, head over to issues@sonatype.org and file a Jira request, and we'll get your information to the right place. Okay, thanks very much. I hope you learned something, and jump on over to the Slack channel. You can ask questions. I'll be hanging out there for a little while, and get connected. Thank you very much.
Awesome. Mykel, thank you tremendously for that. A couple of things as we transition over. I know you're getting onto the Slack channel, so super excited to have you there. As you were presenting, I think one of the key important things there is that we're recording the sessions. So as you're watching live, if you want to go back to something, you're on YouTube, if you want to go back to something and you haven't figured out that you can rewind the session, you can go back to any point in the past within this track and see what Mykel talked about, rewind to a specific slide that he was talking about. So the great part is this is recorded. It will be live on air as we, as we continue to broadcast here, and you'll have access to it even after today. So that's one of the main benefits of being recorded here live online and being on Slack. I think the conversation, you covered a lot of ground, from staging to HA to tagging to the growth of how much new development work we have been doing in the Nexus repository over the years, which is awesome to see that chart. I think the other cool thing that I'm realizing this morning is we started off in Washington, D.C. We went to Las Vegas. We went to Mykel in Toronto, and now we are jumping across the Atlantic to Amsterdam, where we have Stefan and Weeby, who are joining us from ABN AMRO. I know they're on the channel now, so I'm gonna bring them live. You guys can unmute there, and Mykel, you can log off whenever you want.
All right, thanks, Derek.
Thank you, Mykel. Stefan and Weeby, if we can bring you up live on camera so that you guys can turn your camera on, we will be able to start your session. We can see you, so hi to both of you live from Amsterdam. I was just in Amsterdam about 2 weeks ago, visiting Stefan and his team there in their offices. We also had the DevSecOps leadership forum in Amsterdam there, which is awesome. We had a really good community group there, very conversational and interactive. So there's many organizations that are on their DevSecOps journey in Amsterdam, and looking forward to hearing more about one particular company, ABN AMRO, and how DevSecOps works in a large bank with lots of history. There is bureaucracy that any organization has to work through, but I think how they're merging security and development or DevOps practices there is important. So, Stefan, can we hear you?
Hello, can you hear me?
Yep, quick sound check. It works. So
I will share my screen now.
Yep, you can share your screen. And I know that they're both live on Slack for the Q&A, where they'll be after the session goes live. So I can see your screen now. and I can see your slides. So if you want to go into the slide view or the presentation mode.
We are in the slide view. Hello, can you hear me, Derek?
Yeah, I can hear you.
Can you see the slideshow?
Yes, yes.
Okay, perfect. Good. Now, Derek, thank you for the introduction.
Yeah. Do you want to go into presentation mode for your slides so we can see the full screen?
Maybe we need to have this. It's the full screen version, right?
Yeah.
Okay, this should be it.
Yeah, I'm seeing myself right now. So I see your slides.
And now you should see it full screen, right?
Yes, perfect.
Okay.
Okay, Derek, thank you for your introduction. We are Stefan, Simenon, and Wiebe de Roos. We're located in Amsterdam. We are working for ABN AMRO Bank. ABN AMRO Bank is the third largest Dutch bank. And we would like to share our CI/CD journey, how we implemented security in the journey. And yeah, we are looking forward to your question. I'm heading the CV software development and tooling department within ABN AMRO. Wiebe de Roos is part of my team, and he is a specialist on CI/CD, on containers and security. And within ABN AMRO, we have set up a CI/CD program 4 years ago. Before the CI/CD program set up, we used to have a waterfall organization, and we were slow. We found issues at a late stage, and it took lots of time to implement software. We have transformed into an agile organization. Currently, we have about 300 to 350 agile teams working within ABN AMRO, and the CSD journey, it's about tooling, but mostly about a change way of working and a cultural shift, so to say. So what we say, we knew, we know that's a difficult journey, which will take long. We know it's all about improving every day. We have lots of focus upon the way of working and the cultural mindset, but we're not going to discuss it in this presentation. In this presentation, we will show you the technical details, and we show you how we implemented security in our pipelines. So this is the tooling we have implemented within ABN AMRO. We're using Jira, Slack, Confluence for agile management. We use Jenkins for our CI administration. We're using XL Release for our CD administration. And within CI, we have implemented all kinds of code quality tools and security tools in our pipelines. So we have different pipelines within ABN AMRO. For each and every technology, we have a standard pipeline. We have an inner sourcing model to check with our development community their wishes and their feedback. And based upon communities, based upon discussions with our development community, we continuously improve the pipelines. So our development community is actively participating in continuous improving the pipeline. And in this picture, you can see what pipelines we have. Now we are already busy 3 to 4 years with CI/CD. We have already good benefits realized, but there is still more to do. But here I have some examples. In the past, we only did 4 mobile releases per year, and now we do it every 2 weeks, and we're moving to 2 days on a short term. And there is a team which reduced their build from 5 hours to 5 minutes. We already see teams who do continuous deployment, doing automated production deployment right from a commit. And because of the usage of XL Release, we also see teams improving their release timelines. But the question is, what did we do about our security? So we're going to elaborate about 3 topics: secure coding, open source libraries. We have a hybrid cloud strategy, and part of this strategy is also securing our containers, and we have a way forward about credentials management. So what you see in open sources, you see that open source is more and more used within the bank, not only within the bank, but also across the world. You see that open source is a very powerful methodology to use, but what you also see, if you do not use the right open source libraries, if your libraries get outdated, open source might become vulnerable. And what you also see is that the hackers, they are getting more fast to hack systems. So you see an increased threat of being hacked. We all know the Equifax case, of course, but lately we see more cases like India Post, like Japanese Post. We read the blogs of Derek of Sonatype. So what we say within the bank, we need to be secure, we need to be reliable, and securing our software is a key focus for us. So what did we do within the pipelines? We have implemented the code quality and the secure coding tools. We use Fortify for secure coding. We use Nexus Lifecycle for scanning our dependencies. And if a developer is delivering unsecure software, or if a developer is implementing open source libraries which are not secure, then Jenkins will block the build, and the developer isn't forced to fix the issues before being able to continue. In the past, we did lots of secure coding awareness, we did lots of training, we taught, we had discussions with the development community, fix secure coding issues once you see them. We also have provided the IDE plugins, so that developers can already check in the IDE the security. But what we saw is that only limited people were fixing their issues, although they got warning, although they got the feedback. But after we implemented the bill breakers, you saw lots of decrease of vulnerabilities. We also have ensured senior management commitment. We discussed it with our security people, also with the senior management of our departments, because in the beginning there were some escalations and business functionality could not be delivered on time because of the skewed issues. But now we see that there is much more commitment, there is much more awareness and much more understanding. So my advice is use the tools the right way, and also implement quality gates and bill breakers to enforce the development community to fix issues where they are. So, but with this, we only can fix the issues for programs which are changed or for new programs. But within ABN AMRO, we also have lots of legacy programs which are not getting changed. In these programs, we also see some issues. So we are defining now all kind of management dashboarding to make the departments aware of the issues, and we are defining a governance that the management dashboards they need to be discussed in the management forum, and we will check the progress of the fixing of the issues. And once we see areas in which there is insufficient progress, the senior management can step in where required. We did security training. It was already a while ago. We need to redo it. And what we also do is that in the past, we did have SLAs with our ADM suppliers. We punished them if they did not meet the SLAs. We stopped that. Instead of punishing the people, we allow the teams to make failures. We allow them to improve. And the teams which improve a lot, or the teams which share their successes and their failures, we also will reward these teams. So, as I said, the second topic is hybrid cloud. Within ABN AMRO, we have a hybrid cloud strategy. We have an on-premise system, which is an IBM system. we saw that there's an improvement compared to the old situation, but we also see that not all public cloud facilities are in there. We also see that the developers, and they want to work with the latest technology. So we said with an ABN AMRO, we're moving to a hybrid cloud situation, and next to the IBM platform, Microsoft Azure and AWS have been made available. And there is already applications running upon these platforms, 30 to 40. We already see the benefits. But next year, we would like to accelerate a lot. We would like to bring more and more applications to public cloud. And in order to do this, we need to do some more preparation. We need to strengthen our governance, our architecture. We need to keep on improving the security. We need to check what kind of skills are required across the development community and across other communities. And we need to make sure that we acquire and retain the right skills. And I will be leading a cloud native stream. And this cloud native stream is all about designing and developing applications in such a way that we take the full advantage of public cloud. So we will define architectures for microservices or decomposed applications. And we're going to define standard guidelines for serverless development. And we would like to make sure that developers, they are focusing on development only. So we would like to offer a platform as a service. Next to this, we also would like to increase the way of working by containers, by Kubernetes, by Docker. And one important part of this, how are you going to secure your containers? How are you going to monitor the security of the containers? And Wiebe is going to tell more about this.
All right, thank you, Stephen. So if I take over from here about Docker security or containers and security, it closely follows the same life cycle as it is for a Java application, for example, or any other application. So we have thought of security for the coding cycle, the coding phase, the build phase, the shipping phase, and the running phase, because we think security should be in all of these phases within the life cycle. So that their security is needed in every step of the life cycle. So if we then draw a picture or setting the context of all the security aspects here, we can identify from bottom to top. First, we need to secure the Docker engine, because if the Docker engine is not secure, that's like the core system on which the Docker containers are running. So we're now currently looking at Docker Enterprise Edition to see how we can secure the Docker engine all across all the systems at the bank. Then we have containers running that can be on Kubernetes, on Mesos Marathon, Docker Swarm, or even just plain Docker containers, or maybe later on EKS or Amazon or Azure Container Services. And we're doing some proof of concepts here with commercial vendors like Twistlock, Aquasec, and SysDig. Always make sure to always have monitoring in place, logging in place. That's like what the commercial vendors are doing. In the meantime, we are scanning images while they are being built. So we have created a Docker image pipeline. I will come to that about a little bit later. That creates Docker images in a standard way. And we put a lot of security tools already in the pipeline, the open source tools. For example, we are using Claire, we're using Linus, we have Nexus Lifecycle, Nexus IQ. That's in fact a commercial tool, but we already have that in place for other software components, and we extended that to also scan Docker images while they are being created. We also implemented Anchor. That's like a bit of the same, and we're now comparing the different open source solutions to see similarities and to define policies based on security findings. Next to that, on top of that, we should provide a way to sign images. So if we build images, it's like we will sign them to make them ABN AMRO approved, and then once they are approved, they can be pushed to Bitbucket or to Nexus or another repository, so that other teams can safely use it. The same goes for Docker secrets. There's another slide on that. And on a very high level, we should, just like other tools, we should check the code. That means we should check the Docker image file on a code level, and we use ado lint for that. And if one of these phases, if it breaks in the pipeline, then you cannot continue with the next phase. So why all this effort? The main reason is preventing container outbreaks, preventing bad quality, preventing systems at risk. So we see a broken container here. That's something we'd like to avoid. So as I said, we have a Docker image pipeline, and that Docker image pipeline basically runs on Jenkins. We have Jenkins Enterprise being implemented on AWS in the public cloud. That Jenkins Enterprise is also based on containers. So it's like containers everywhere. Basically, if a developer wants to create a new Docker image for his or her pipeline or his application, there will be a push from Bitbucket, from within Jenkins. It will trigger a Bitbucket, getting all the sources. We're building that Docker image, and then all the security steps from the previous slides will start to run. So first we check the syntax with Docker lint. Then we do a dependencies check. We're getting a report from Anchor. We're getting a report from Nexus Lifecycle. We're doing a configuration check of the containers about naming conventions, best practices. That's how we want it in the bank to act as a standard. We're applying some security profiles if needed. We're doing a very simple smoke test, starting up a container. For example, if we want to have a container with a Maven, there should be output like Maven and a specific version. If that doesn't come back as a return value, then it's invalid, and then your whole pipeline breaks. And then you see it here, you should go back and fix that. But once everything is successful, we're signing the Docker image, and we're publishing it in a trusted registry. So then it's ready to be used by other development teams. So that's basically about containers and security. Next topic that hooks up with this is about credential management. It's like all the processes and technologies about secrets, passwords, API keys, and certificates, how we are going to work with that, how that's being structured, what are the processes about, and what are the best practices to work with all of that. And it also applies to the Docker containers here. So if we take a look at the history about credentials management, on the top left, you see credentials are being stored in the code. It's in plain text there. It's in a configuration file or an environment variable, and it's very much decentralized. We're now heading towards a solution in which we opt for a centralized management of credentials. So in the first phases, we have it, for example, being put in Bitbucket, maybe in a secure file. But we're now heading towards the implementation. We're doing some POCs with HashiCorp Vault, Keyfold, CyberArk, and that's like the way forward also to work with Docker and security and Docker and containers in here. So if we hook up, why are we doing all this? It's like there are so many use cases already on the internet about risks. So we have seen breaches in the past about Vine. There's a hacker that hacks a Docker registry. Well, we don't want that because there's also stuff inside that can be read relatively easily once it is being compromised. Or in Uber, there's also a public registry that's being hacked, and that's a very secret key that was being stolen because it reveals so much information about drivers of Uber cars. And there's another case from Ashley Madison that, well, developers, they are storing their credentials in the source code and also putting keys in there. We would like to avoid all of that because that's putting the bank at risk. So basically, we have secrets now in source code. Secrets are being used in orchestration levels like Jenkins, Bamboo, Circle CI. And we have secrets on deployment phase, for example, Azure, AWS, or Rackspace, whatever. So basically, we have keys, keys, keys. We have secrets, and those secrets are everywhere. So that's why it is very important to have a centralized solution that every developer and every department can use. That's very important because now almost everyone said, according to a survey by CyberArk, said, well, 99% don't know of the people that responded, they don't know where the secrets really are. So if you don't know where all the secrets are, then you're at risk exposing secrets while you even don't know where it is being exposed. So the focus areas about credentials management here is we're doing some stuff about key rolling. We're trying to provide granular access permissions for all the tools and all the applications to find a generic way of setting those permissions. We have a secure storage. We want to have audit logs. We want to have monitoring also for Docker containers here in place. It's a very big topic right now. It should really fit into the DevOps environment. So that means we're talking about DevSecOps here. And of course, with containerization, it's even more important to have it all in a very good place, all in a centralized place, especially because containers are, well, disposable once the container dies or crashes or it's getting disposed because it's not needed anymore. That's the, well, key value of a container. You still want to know if something bad happens during the life cycle, during the lifetime of that container. Well, that's it for now. Thank you.
Excellent. I'm back on. So Wiebe and Stefan, thank you for your presentation. It was you know, I got to see some of that when I was in Amsterdam a couple of weeks ago, but I think like any of these presentations, you know, if you watch it a couple of times, you always learn something different. I think, you know, some of the key values that come out of that presentation, especially for those kind of getting started on their journey, are the DevSecOps reference architectures that you have. So what are the combination of different DevOps tools, you know, like Jenkins, or DevSecOps tools like our Nexus products and HP Fortify and others that you put within your pipeline? You know, what are the choices that you made? How are you integrating those together? Are of key importance. Also, I'm really glad that you spent, you know, more time on the container security topic and secrets management topic, and hopefully we can extend that conversation in the Slack channel, because I think, you know, as we go, you know, across the different communities and out talking to people in the DevSecOps community, the number of people that are talking about container security has been increasing. For those of you that followed the DevSecOps survey, community survey that we released at Sonatype with a lot of our community partners back in April of this year, you know, we asked people, where are you automating security across your development lifecycle? And as part of that, not only did we see DevOps organizations increase the use of automated security throughout the lifecycle more than non-DevOps shops, but when we asked them what investments are you making in DevSecOps or automated security technology, the top three were web application firewalls, container security, and open source governance. So those rounded out the top three choices of automated security for folks. If I have time throughout the next sessions, I will put a copy of that survey on the Slack channel here. So if anyone wants to take a look at it or has any questions on that, if you haven't seen it, I will load that into the Slack channel. So we have a couple of minutes before we start with Hiep Tran from the Capital Group is joining us live from Los Angeles. So we're going back across the Atlantic from Amsterdam to Los Angeles. Hiep is with the Capital Group and is going to talk about how they've deployed our Nexus Lifecycle products within their environment, how they're managing DevSecOps at scale across more than 1,000 applications today within their environment, the business use cases for putting that together, the challenges with putting their practices, DevSecOps practices together, and how they've overcome some of those. So we'll be on break for just a minute or so, and then or a couple of minutes until we get to, I think the starting time is 11:45. So if you'll be patient, we will be back with you soon. And I will, of course, be live on Slack here. If anyone has any questions for me, maybe before the next session starts, I'll put the survey deck live there so that people can see it. And Stefan and Weeby, if you can hear me and you have an opportunity to upload your deck into the Slack channel for people to see, I think that would be greatly appreciated as well. So I will be back in a minute with Hiep, and we'll see you soon.
All right.
Thank you.
Thank you. Bye-bye.
Bye.
Okay, we are back live. Hiep Tran is on the line. We're going to get, we've been chatting back and forth on Slack. So Hiep, when you can hear me, if you can unlock or unmute your microphone, we can have you join us here. You are unmuted. So let's do a quick sound check. It sounds like I can hear you.
Hey, Derek. Can you hear me?
Yeah, I can hear you loud and clear. You want to share your screen, and we can just make sure that that works and get your slides available. Okay, and let me get your slides presented. Okay, so I can see your slides in the full screen here. So I did a little introduction before the break, but as we're going to break each of these individual or sessions up into individual sessions for recording playback later, let me just introduce you now. So Hiep Tran is at the Capital Group, Senior Technology Lead, DevSecOps Solution Engineer at Capital Group. I'm really excited to see this presentation. One, because I haven't seen it at any of the conferences that I've been at lately. So it's always nice to see new presentations, new content out there to hear what people are doing with DevSecOps, especially at scale where you have over 1,000 apps within your environment that you're going to manage. So I think the lessons learned here, some of the business use cases that Hiep is going to cover, as well as some of the challenges that they have within their organization, as everyone does in their DevSecOps journey, and covering some of those. So I'm super excited to hear this conversation from Hiep live from Los Angeles. So we just crossed the ocean back from ABN AMRO in Amsterdam to Los Angeles with Hiep at Capital Group. And I'm going to hand it over to Hiep to get started. I'm going to take some notes, and we'll also look forward to seeing Hiep in the Slack channel. And I already see Mykel Alvis is on stage as the next presentation coming up after Hiep. So you'll definitely want to continue to stay tuned after for the next presentation coming up. So Hiep, without further ado, let me hand it over to you.
Okay, thanks, Derek, for the introduction. Good morning and good afternoon, everybody. My name is Hiep Tran. I'm a senior technology lead at Capital Group, and it's my honor to be here today to walk you through our journey of implementing our CI/CD pipeline with the Nexus platform to enable DevSecOps. So before I get started on our implementation details, I want to provide some background on our current landscape of our portfolio stack and what our current pipeline looks like. So we have over 300 applications based on 4 main technologies: Python, .NET, Java, and Angular. These 400 applications also integrate with various database platform as well as the middleware platform, which have over 1,000 components. So these 1,000 components are currently on our CI/CD pipeline. Our pipeline leverage heavily on the Atlassian stack. We use Confluent for collaboration and requirement gatherings. We use Jira for Scrum, Agile, and task tracking. For Git hosted repository, we use Bitbucket server. Our CI/CD main engine is Bamboo. We use the Nexus Repository to manage artifacts and libraries. And recently, we integrate Nexus Firewall and Lifecycle into our pipelines to provide third-party libraries scanning. We have Sonatype for continuous code queries, White Hat for SAS scannings, and at the back end of our pipeline, we leverage ZBL Labs, Excel Deploy to do the deployment to various technology and platform, and Excel Release for release management workflow. We're starting to shift toward converting our application portfolio to the Docker and container platform. So we're doing our new CI/CD pipeline using Jenkins as a main engine. So for the last 8 years or so, we have a lot of challenges within our pipeline or our build CI/CD environments. we don't have a proxy repository. We only hosted the repository inside the Nexus repository, and these are for good reason, because there's no governance process around it. There's no policy enforcement, and we don't want anybody to use any version of library or component out there. And this is the only way to prevent people from using bad components. Because of this process, it's introduced a manual upload process for any new library or component that the developer wants to use. They have to follow a ticketing system process to upload libraries. And then, if you run into a transitive dependency nightmare, that's why you keep following the ticketing process, which is very inefficient, costly, and cause loss of productivity. This also causes low morale from the development communities. There's low uses of the Nexus repository. Most of the time, if they want to use new library, they just work around the process of checking that into source control and reference that that's library that we're checking into source doing their build as part of their build process instead of referencing from the Nexus repository. We don't have no informed decision. The developer don't know what our current standard, which version they just be using. So most of the time, the application stack are using all outdated technology. There's no metrics or reportings. We don't know what teams are using, what version or which components. And then, at any time there is a new critical CV, for example, struct, we will have to use really low scanning tech, like scanning the source control, as well as scanning build logs, trying to figure out what version or what component application team are using. Those processes are not very accurate and not efficient at all. And then we don't have no monitoring to the application that currently running in prod. So if there's a new vulnerability that comes up, we're not being proactive on trying to remediate. So with that, with those challenges, we set our business objective to be, we want the next next version of our pipeline to be able to vet all the components that are gonna come into our environment. We want to have some policy enforcement around what kind of component libraries application teams should be using. We want to shift left, empower the developer to make informed decisions from within the IDE, and instead of waiting to the last minute when the build about to go to prod, then they find out that they're using some bad components. We want to boost productivity and reduce costs, so we wanted to automate this whole workflow inside of CI/CD pipeline. So we want to follow DevSecOps best practices, as well as providing some kind of metrics so that we can continuously improve our code quality. And then continuous monitoring, we want to continuous monitor production app to react quickly and remediate any vulnerabilities or any CV that comes up. So with our implementations to all those objectives, we bring in the Nexus Firewall and Nexus Lifecycle. The Nexus Firewall, Nexus Lifecycle enable automatic policy enforcement. It blocks bad components from coming into our environment. It promotes creativity to our developer to be able to try new technology quickly and be able to turn around the time to market faster. And with the firewall and then Nexus Lifecycle, we were able to implement the proxy repository out to the public repository, to Maven Central, NuGet galleries, and the NPM registry. And we were able to, with the firewall and the lifecycle, also enable us to report on the uses of these components. So now we can run report and be aware of what the application team are using and have automatic scannings. We implement the IDE integration with Nexus Lifecycle as well. So within their favorite IDE, the developers can quickly run the vetting process and go run through the policy, and they were able to make informed decision on which version or which component is approved, which one is not. And then we integrate the IQ scanning portion of the Nexus lifecycle into our CI/CD pipeline. So now every build, every release that going to all the environment will have this automatic IQ scanning for bad components, so that it will stop a build that introducing a bad version to the environment of an applications. And then we have continuous monitoring. So at midnight every day, the Nexus lifecycle rescan all the bill of material to detect if any new CV that happens, and then it would alert us so that we can remediate quickly. And also we build an automatic governance process for the remediation process. If there's any policy violations, or if the file was blocking any bad component, if continuous monitoring detect any CV in our production app, is automatically integrated with Jira to create a ticket to raise awareness for a governing body to react on it. So this is a high level of where we leverage the Nexus platform in our CI/CD pipeline. So we have the firewall that would block the public component from coming in to the Nexus repository. We have the developer in the IDEs interacting with Nexus lifecycle so that they can vet our component that they want to use. As soon as they enter a new library into the POM file, they're able to see right away which policy if this component is violating, and they can quickly use the Nexus lifecycle to pick the correct version or a different component that they want to use. And then as part of the CI, the build process would go to the repository, and the firewall will filter out if any component that the build want to bring in uses. And then we have, as part of the CD process, we automatically do IQ scanning on every packages that going out to all the environments. If any policy violation is detected, it would block the build and the releases from going out, and create a ticket on the dashboard so that team can react on it. And the lifecycle continuous monitoring also monitor the application in production, so that it can help us react quickly to any CVs that's just happened. And this is our governance workflow. So you can do an ID policy check from the Nexus repository. If it's not approved and the firewall filter it out that based on some kind of blacklisted or using a bad component, a bad version, it will automatically create a ticket on Jira with automatic email a governing body to alert that a developer is trying to use a blacklisted component or something that's banned, and then the governing body can work with the developer to either approve it or reject the request or waive the policies, and this doesn't apply to the application. If the developer decide to use it anyway, even though it's not been approved or rejected, then our CI/CD pipeline will actually do another IQ scan before it deployed to the target environment, and if detect any violation as part of the scanning of the final package going out, it would email the developer to fail the build, as well as create a Jira ticket and alert the governing body as well to react on it. If the developer uses an approved component, it's go to the pipeline, it's deployed to prod, continuous monitoring run at midnight to rescan the bill of material, and if it detect any new vulnerabilities, it would create a Jira ticket and also email the governing body to help the application team to remediate that quickly. So with any good system that you build, if you don't have a lot of uses of it, that's a failure. So we have over 1,000 build plan in Bamboo. So it's our goal to enable IQ scanning on all our apps in our CD pipeline with no involvement from the app teams and no impact to the pipelines. So this is our one for our onboarding. With that, we were able to leverage automations, REST API, Python, and Selenium to onboard of our over 1,000 components. So in order to onboard to the Nexus lifecycle, you need two parameters or two pieces of information. One is the application ID, and also the role and the entitlement, so that for that application, so that the user, it's the developers or the dev lead, can go to the dashboard or the reporting engine from the UI to view the policy, as well as any information from the scanning. So we need those two pieces of information, and we know that Bamboo map one-to-one with the Nexus lifecycle from one application to application, and the application ID is actually is going to be passed from Bamboo as part of the IQ scan to figure out which application in Nexus lifecycle to upload the report to. So we know that we can get that information from Bamboo. We just need the entitlements and the role and the group, the AD group, with all the members who belong to the developer group, who belong to the dev leads, and that reside in our Bitbucket application. So we wrote a Python script that make the first REST API call. It would create Bamboo for the application names along with the app ID, and it would use the app ID to create Bitbucket to get the role and entitlement, and then we union the data to get the two parameters that Nexus lifecycle needs. And then the third call would be calling a REST API call to the Nexus lifecycle to onboard over 1,000 components into the onto the Nexus lifecycle, as well as having the correct team members and their role and entitlement without their involvement trying to get on. So the next part is to create additional step into our CI/CD pipeline. Bamboo REST API is limited to what action you actually could do. So we can really use a REST API. So if you want to use, you want another step to the Bamboo workflow, it's not as flexible as Jenkins, where you can have a Jenkins file. You have to manually go to the UI and edit the Bamboo build plan. So we were able to write another Python script that leverages Selenium that go to the front end of Bamboo and edit its individual plan, add the additional steps to that CI/CD pipeline, and then it's going through several hours to enable automatic IQ scanning for over 1,000 apps. So what's next? We will continue to improve our current process of our governance to provide a smooth working workflow between the architecture team, the risk team, the license management team, as well as the apps team, to increase the speed of the remediation of the policy violations, as well as improve the quality of our code. And we started to convert our portfolio to the Docker and container platform, and Nexus is our choice for Docker registry. So we plan to have at least 3 Nexus registry in the Nexus repo, as well as build a promotion workflow on top of it, so that we can promote the Docker images from one registry to another, and then enable IQ scanning for Docker images as well. And then the important part is the Nexus platform run really well within the Docker container as well. So we actually started to convert hosting of the Nexus platform inside the Docker containers, so that we can scale up quickly and have high availability capabilities. Success stories. So when we implement this Nexus platform integration with our CI/CD pipeline, we were able to prevent 50 critical CV and license ban from going to prod. Struct, Spring.js, it's create really high morale within the organizations. The risk and architecture team are very happy now that they are equipped with report so that they can managing the workflow governance of the component and the library. Managements are very satisfied that our builds are now having a high quality as well as high security aspect coming from it. The developers are very excited now that they enable to try out new technology quickly, and they were able to be very productive. I think that's all I have for today. Thank you for listening in, and please continue the discussion, or if you have any Q&A for me, please feel free to send me a message on Slack. So thanks again, and enjoy the rest of your day.
Okay, Hiep. So that was excellent. So thanks for going through all of that. I was taking notes as quickly as I could because you talk fast, and I captured a lot of screenshots as well. So I'm sure there will be questions in Slack. If you don't mind, I have a couple of questions for you that we might just cover live here. So you mentioned earlier in your presentation that there were, sorry, let me get the screen over. So you mentioned earlier in your presentation that there were, you were beginning to track the number of components, the open source components that you were using in development. Once you did that and you started to get visibility to it, were you surprised at how many components there were within the environment? Did you expect to find the number that you did in your organization?
No, we didn't realize how much. We use so many open source components from, we were surprised. There was a lot, and so the number and the metric were very surprising, and it's really help us now that we have the data and the number. It can help us to go forward and start building out our policies on how we want to handle these components.
Mm-hmm. So it's always, I've talked to a number of different organizations that kind of have the same reaction, that they know they're using open source, they just don't know the volume of what they're using within their enterprises. The other question that I had, and I wanted to go back to what you had talked about earlier, was you talked about the development practice that you have using Nexus Lifecycle, using the IDE integration and the build integration with Bamboo, and I think Jenkins as well. In your environment, you said you'll stop the build process if a developer is using a vulnerable component that doesn't meet your governance policy of what's allowed to go through. Was that did you take a stepping stone approach to that, meaning you were monitoring first without restricting or breaking builds? And kind of what was that journey like with the development team? Did you just turn this on one day, or was it a gradual transition that you had into kind of the breaking build mode?
It's a gradual transition. So one thing we don't want to do is when we onboard over 1,000 apps. So the least thing we want to do is have any kind of disruption to their build. So we start out with warnings, and then we gradually move the warning to fail build, and it's the warning starts to happen on the development branch, but any build on the release branch are gonna go out to prod. We will actually fail the build. So, but it's a gradual process. We warn first, and then we make sure everybody who have any policy violation would receive an email, as well as have the management involved into the process of trying to remediate and being raised, just be able to raise awareness. That was a great thing that we didn't have before. That we didn't know what team was using, and now be able to have the data as well as to raise awareness, and that was a big thing for us.
Mm-hmm. Yeah, so it's interesting to see how you're able to apply different levels of policy or different stringent levels of policy as you get closer to release. The policies get more strict. Earlier on in development, the policies can be a little looser to allow the innovation to happen without slowing development down, but you know what you're releasing into production. One last question, if I could, and that is, you mentioned struts. So, if you're using struts in your environment, was there kind of a red alert at the time that the Equifax breach was announced and linked to struts, or was this something that you were more aware of even before the kind of big struts headlines back in September? Was there any kind of greater sense of urgency after September, or was it already existent in your environment with that vulnerability and breach announcement?
Yeah, I think Struck was already in the environment, but with the Equifax announcement, that's actually raised some awareness to management, and then without the platform, as I mentioned, in some of the challenges that we have is that we have to follow some very low level process. We're scanning for build logs, we're scanning source control. There's no good or accurate way of detecting which application are going to be using structs. So with that, we feel like there's a need for the Nexus Lifecycle platform which is very valuable to our pipeline.
Awesome. Well, I'm going to let you jump into the Slack channel now. I'm sure there are questions there that people have, and definitely stay on. And if you have questions for our other presenters or community members that are there, our speakers are allowed to ask questions too. They're not just there to field questions. They're all part of the community. So, Hiep, thank you again for joining us this morning from Los Angeles. We'll see you in the Slack channel, and I'm going to bring on Mykel Alvis, a good friend of ours from Cotiviti. And okay, Mykel, it's good to see you live.
You and it seems like years now.
Yeah, I know. It seems like I used to see you every couple of weeks. Mark was standing here behind us.
Right.
So, yeah, we used to see you, it seems like every couple of weeks at conferences, and then I couldn't make it down to Atlanta. I think you were at DevNexus back earlier in the year, and I was off somewhere else at some other conference. So
it's almost like work, man.
Yeah, I just think back to the taco place in San Francisco and the heavenly tacos that we had there. So
yeah, I'm gonna miss the fact that DevOps Enterprise Summit isn't there this year.
That's right. We're gonna have to find a new taco place in Vegas. So if anyone has recommendations on Slack that you can drop us for where we need to go and get tacos there at DevOps Enterprise Summit in October, we'll take the recommendations. So Mykel, glad you could join us. Mykel, a longtime Nexus user. I've seen, like many of the speakers that we have on today, I've seen speak at different conferences that we've both been at, but I don't think I've seen this latest presentation here. So yeah, so we might. Are we the test run for this?
But you're the first one that I can't shame into silence, and that's what really matters.
Excellent. So why don't we can see you, we can hear you. Why don't we get you to share your slides, and we can kick off this the conversation with you.
Apparently, I need to share my entire screen. I need to do this, and then I need to do that. And how are we looking?
Perfect. You are golden.
Great. Hi, everybody. I'd like to thank Derek and Mark and everyone at Sonatype for the opportunity to speak today. This is a very different presentation from some of my other presentations. Usually I'm just basically a giant jerk and call people names. This time I'm only going to call people names. I think I'm not being a jerk that much. But this particular presentation started out something very, very different. It started out as a more philosophical, conceptual thing. But over time, it became something about specific technologies. And I think it actually resonates, but it can be very challenging to grasp the whole point. So I am perfectly willing to spend time explaining it afterwards, assuming that I don't get my point across. So the real deal here is that pretty much everything sucks in software. It is a giant pit that is trying to destroy all of us all the time. It's eating everything in the world. It makes everything good and everything bad. I love Amazon Prime, but you know, the truth of the matter is that I also like corner grocery stores. So as we proceed forward into the future, I can only expect that everything is going to continue to suck even more, and that we will try to produce some sort of magic in software that reduces the suckage of everything that we can find. I am Mykel Alvis. You can find me pretty much everywhere as at Mykel Alvis in some way. I am the DevOps coach for Cotiviti Labs. Labs is the R&D function for Cotiviti, which is one of the leading providers for payment processing accuracy in the healthcare claims space. So I work with extremely dangerous data. I work in a very aggressive environment, and I work as my job is to reduce risk in that environment as much as humanly possible. That has been the job that I've had a lot for the last 14 years, but I have been a software engineer for 41. I'm starting in my 42nd year as a developer. And across the last 14 years, I have been deeply observing the process engineering space. I have about 40,000 hours of work in that space right now. And that is not one of those moments where I go, you should listen to me because I am an expert in this space because I have more than 10,000 hours in it. That is not the case. The reason you should listen to this is because of how many times I've screwed up across that time and before it. I've given a number of presentations about the ways that I screw up. I've given a number of presentations about the ways that I have pulled myself out of that mud. And this particular one isn't one of those. This is just a new thing that we do, a relatively new thing. You, on the other hand, have a job. You're trying to create order from chaos. You probably have a lot of trouble with repetition. Repetition, humans love it, but they're not really particularly good at it. You're trying to merge some operational discipline with some development work. You're basically trying to merge change with static behavior. And probably you're held accountable for the results. If you're here, this is probably interesting to you because you're looking to reduce the risk of this problem. Now, we could start at the very, very beginning. First, there was this big explosion and the universe came along, but I'd prefer to start in about right around the mid-90s. So I've been writing software since the 70s, but it was really terrible until the mid-90s. In the 90s, we had a lot of, then software became a new thing. It became a much more compelling behavior in society. Computers became cheaper. It became more prevalent and pervasive within business, and the tooling started getting a lot better. The introduction of Linux was in most of that period. There was a big shift in the middle of the 90s. There was this thing that Sun did called the JVM that gave a relatively isolated runtime in a space where that wasn't the case anymore. It had not previously been the case. And so most of my work since probably 1997 has been in a space that is in or around Linux and the JVM. And for that period of time, if you are familiar with the breadth of it, tooling started out being really, really terrible, actually non-existent. When I was in the beginning, I built with make files. Actually, I built with shell scripts. Actually, I built with batch files. And so as we proceeded forward and the tooling became more important, there was this sort of cultural shift about tooling that pushed us toward a more unified way of dealing with our software problems. Tooling was wasn't even remotely big. The biggest thing that I can remember in the 90s before the JVM was Rogue Wave tools, which cost a fortune. It was a giant C++ library that had 12 feet of documentation and was really difficult to use most of the time, but it was basically the tooling you had, that and make, people. And so we've got this kind of push toward tooling, and tooling is really a great thing. And tooling helps us impose determinism. Now, determinism, in a general sense, is unavailable to us. You cannot control, you don't control the underlying physics of the universe. So nothing is truly deterministic. I also believe that chaos is only sort of a thing, though. I think everything more or less happens for a reason. I think that there's probably some, series of atomic collisions that occurred that made me show up at this thing today. And probably those things could have been predicted if I was way smarter and much more perceptive than I am now. But chaos is just sort of a thing. Imposed order is sort of desirable. You don't want statically, externally imposed order. You kind of want to make your own order. You want things to sort of work the way you want them to. And tooling helps you do that. Tooling helps you increase the order and thus increase the determinism and the predictability. And the reason you want predictability is because it allows you to keep your promises. Now, people tend to work because, or they tend to be in software because they have work, and they tend to work because they get paid, and they tend to get paid because they do real stuff. Employers have a strong tendency to look negatively on it when you don't produce those things. When you're not capable of delivering results with some frequency, it can be very challenging for an employer to consider your continued value. You, as a consumer of tooling and software, are really looking to produce some degree of predictability so that you can provide some assurance to someone. So collaborative assurance is actually a really big outcome from good tooling and from good tools and from good processes and practices, which are themselves cool tools. So when we talk about promises that we're making to people, promises they come in a wide variety. This is the Webster's definition because I needed something to put on the slide. But they really are this is really kind of it, right? It's a reason to expect something, especially something with an expectation of success. When I promise you that I'm going to show up to your birthday party and I don't show up, that makes me that I've let you down. I've actually broken a minor social contract. I probably had a good reason, mostly because I didn't want to come to your birthday party. But as a tool, as a way to handle social interaction and actually non-social interaction, even technical interaction, promises are sort of a really big deal. Some of you probably are aware of Mark Burgess's work in promise theory, which has a much wider reaching implications than just in software. But to be honest with you, that it turns into a philosophy discussion at that point. And mostly what I do is I have a job and my employer expects some results, and therefore I'm interested in it because it produces some kind of outcome. I have systems. Those systems, rather than being constrained by their promises, they are actually, what they do is they actually reduce the number of promises they make, and we do a really good job of trying to keep those promises. Promises actually do this really cool thing. They give you autonomy in decision. You can decide whether or not you're willing to accept a promise that somebody wants you to make. If you have a significant other of any sort, probably what happened is somewhere along the way, you asked them to make a promise to you to attend some event. We'll call that event a date. And under those circumstances, that person probably showed up. Now, they didn't have to. They chose to do this. The act of choosing actually produces a positive output. Humans get dopamine responses when people actually do things that they say they will do. You like it when people keep their promises. And this autonomy of choice means that it's not a compulsion. It's actually something that we want to do. And this autonomy exists within a potentially complex space-time, like the real world, which is an extremely complex space-time. There's a lot going on here. Again, I didn't show up at your birthday party. because I didn't want to, but I really didn't want to because Westworld was on. So it was there's a lot going on out here, and we don't always have the capacity to understand the scope of what we're agreeing to. But when you make a promise, your social capital is bound to your ability to do this. Everybody has this person in their life that never keeps their word. They never keep their promises. Heck, they don't even keep minor social commitments. We're not talking about laws here or SLAs where, jillions of dollars get lost. We're talking about your friend Tony, who he can't be bothered to show up to the movies that everybody was going to. He can't return phone calls. Everybody has this friend. Probably, if you don't have any friends like that, as the saying goes, you probably are that friend. And so it is truly important that to maintain correct social capital and live within the construct that is society, that you have to be able to keep your promises. I know this sounds very kindergarten, like don't promise what you can't deliver and all that sort of stuff. But this has really serious real-world implications in software. One of the better ways to produce a delivery that keeps the promises is if you produce something that is in fact immutable. And I'm going to explain why that is. There's this promise. I promise you that this system will stay up 7 nines. Okay, well, because I'm an idiot, I decided I would accept 7 nines of uptime. I promise you that it will. Now, the amount of change that is in that system, the amount of delta that goes through that system and that gets eaten in that system induces some of this chaos that leaks in from the outside of the world. The more that leaks in, the more likely that there is to be something that you didn't take into account. So the less change that you do in a thing, the more likely it is to stand, well, let's say in that case, 7 nines is basically permanent in the scheme of things. That as an output, the immutable delivery of a thing allows you to reason to some degree about whether or not it's going to stay alive. Now, we work in a cloud environment, and to be honest with you, sometimes that thing goes down. I don't have any control over that. I like not having any control over that because I like not running a data center, and I like not racking and stacking hardware, and I like not having to push and pull network cables. But there is a little cost to this, right? So now we're down to the question about determinism and why you aren't really deterministic. You don't control the underlying physics of everything. If you did, you'd be amazing, and you would never have downtime because you would simply will it not to be so. But in the course of determinism within your system, what you're really trying to do is get down to the level that you are capable of controlling. And that's where you make your promises. I promise that as long as my cloud provider provides this thing, that I will attempt my best to do this other thing, like keep your system alive. And to do that, I frequently have to produce something that is relatively immutable, or I've got a moving target on my hands. Now, we handle this in the course of producing things through builds. Most of my process engineering life has been in build and build management. I believe very deeply in a build-centric outcome. I believe that in the course of a build that you can make a lot of decisions and you can keep a lot of promises by simply aborting a task. We've had several people talk about how they abort a process before something terrible happens, before a bad piece of software gets included as a dependency, before an untested piece of code goes forward, before anything happens. When you get to the deployment of a thing, and deployments are themselves nearly as durable as they used to be, but when you consider that by the time you get to the deployment of a thing, you're really committed to a certain degree. So you kind of want to push as left as you can. You want to make the fail happen as fast as possible. You really want it to happen before anybody tries to do anything of any real value. And that's where the systems that we are building right now are based. The concepts are based on the idea that we are trying to produce
It looks like we may have lost Mykel there. We're going to get him back on in just a second. Yeah, once we'll get Mykel back on the Slack channel, let him know that we dropped, and then we'll go live again. Sorry for the inconvenience here. Sometimes happens in a live environment.
Hey, where was I?
Sorry. Hey, Mykel.
Where was I? What thing did I say last?
You were just had passed the slide with the life cycle on it.
Okay.
So
cool. I'm back.
I was just tweeting that you were doing a great job. So
and then it turns out that the tab sleeper in Chrome is a weird thing. Let me see if I can make that just not ever happen.
Okay.
Disable that. Before we move forward, I'm going to just disable this thing. I think I'm going to disable this thing. Let's say that.
Yeah, no worries. We can edit this gap later in the presentation.
You know,
we're just taking a lunch break, so we don't. We're not preventing anyone from speaking.
Okay. Well, great. Yeah, I can't figure out how to make this happen. I'm not that smart, so I can just if I die again, then I will try to just ping me.
Well, at least you know that you died. So.
I know I died. No, and I do now. Actually, Amy told me. So we're back. So I'm going to go back to sharing and this and that. How are we now?
We are good.
Okay. So again, to reiterate, because repetition, process induces deterministic outcomes. Determinism induces predictability, and predictability allows us to keep our promises. And fortunately, I used a pejorative in the middle of that, so it's probably pretty good that I was off. Our definition, my team's definition, is anything that meets your release criteria, whatever that is. You can have a bunch of criteria. We have a bunch of criteria for what our release criteria is. People work on software all the time, but until it gets to the point where they have met our release criteria, it's not a real thing. It's just kind of whatever. Sure, bro. You got some cool code. Great. Congratulations. For our definition, a release produces an immutable artifact that we store in a known location with a unique n-versioned identifier. If this all sounds very Maven-centric, well, congratulations. You made it to the party. Releases also imply a process, some mechanism that produces this. Within our system, it is always a Maven build. It is a Maven 3.5.3 build, to be specific. It is always a Maven build. We don't build any software any other way. Now, I have worked in a lot of teams across time. And everybody that shows up on my team is like, oh my God, why are we building Maven? It's so terrible. I'm like, well, it's because you don't know what you're talking about. Because I'm not looking for things that make life easier for you. I'm looking at things that make life easier for the company. I am looking at this from a purely holistic viewpoint. Now, can you get the same results with another tool? Of course you can. Of course, it's Turing complete software. You can do it with bash scripts if you want to. In our case, we do Maven releases because it has a formal release process and because we have a system that does it by bots. So our releases are actually untouched by human hands. And we treat every single thing as if it was software. Everything. We treat everything like it was software. We build it, we test it, we release it, and then we deploy it. We keep our releases safe, and we never change them. They are as immutable a thing as we can possibly make them be. Again, at the constraints of determinism. Our criteria are that we follow the Maven release formal release cycle, which is for people in the know in that space. It's a release, prepare, release, perform. We require a specific amount of test coverage on your application. I prefer 100%, but I'm also not insane. Well, possibly not insane. We'll see. And then we have a bunch of security stuff that we want to pass in this process. When we have security scanning in your build process, suddenly vulnerabilities can be sort of a software problem. We can actually talk about these things as if they were deficiencies in the software rather than some behavior that some person made. We build our stuff with our bots and we deliver it specific to our repository, which in this particular instance is, as you guessed it, Nexus. Now, I've used Nexus for a really long time. I've used a bunch of other repository managers, and to be honest, well, there's reasons. So our promise, we really produce one, but we have this kind of secondary one. The promise that I make my people is not, I will keep your application running. I'll try, whatever, but I'm not promising anything. I promise that I will do everything I can to ensure that access to a given released artifact remains possible within the constraints of our information retention policy, obviously. This is actually a fairly low risk promise. It's actually pretty easy for me to do this. I restrict the people who could possibly make that not happen. I have a team of people who are able to make it happen, who simply won't make it happen because they know that we have made this promise, and we're all kind of on board. We have a social construct that says, hey, I'm not going to delete the blob store that backs Nexus or anything in it. And that's a pretty easy promise to keep because it's a promise to not do something. It's not a promise to do something. It's a promise to avoid a potentially damaging act. The other thing that we promise is we're going to keep your system alive for just about as long as it takes to replace it. So if it took 2 hours to deploy your system, I'm going to try to keep it alive for 2 hours. That's my promise to you. So we'll keep it alive. But if your system keels over right at the end of deployment, it only runs for 20 seconds and then it keels over, then right as soon as I start deploying your stuff, I'm going to try to start deploying it again somewhere else. That is a substantially riskier. It's not actually slightly riskier. It's a substantially riskier behavior. Now, for the shameless plug part of the presentation, why did we pick Nexus? There are other repository managers. We've used them. I've used them. Our teams use them. Repository management isn't really optional in modern software development. If LeftPad taught you nothing as a JavaScript developer, having a repository manager is super helpful. And because modern software management is done in a dependency chain, these things all kind of understand each other. Sonatype has a substantial amount of experience dealing with this problem. They focus on how these things are proceeding forward. They have good features and they build new, intelligent new features. Honestly, the reason we keep it is that I have a great deal of faith in the stewardship of the application itself, specifically of repository manager. I have a great deal of faith in those people because they have, you're sitting there looking at them a lot of the time in this conference, but those people have never let me down, literally never let me down. Now, the first time they do, it's going to be kind of crushing, and they will eventually, but it's not really, I don't really expect it to happen anytime soon. In fact, maybe not into my lifetime. But the primary reason that we pick Nexus is the reason we pick any repository managers, because packaging is literally everything. In software delivery, packaging is everything. There is nothing beyond it. We talk about containers as if they were a magic new thing. That's just a package of running stuff, or a runnable package of stuff, or however you want to call it. It's an executable for practical purposes. Well, Ruby gems are this amazing package. No, they're not. They're just another package. They have dependencies. They all work, right? Maven built POMs are descriptions. They're models of packages. Yep, that's all they are. So packaging allows you to collect things in an intermediate form with a temporal and interface signature identity. A thing that you can you can reason about the identity of the contents of a package by simply looking at its identity. And you can look at it in relation to the identity of other identities. If you don't know how this works, then go look at a Maven POM, or go look at a gem file, or go look at an RPM spec file and see about how all the different versions of things interact with each other and how they expect to be able to interact with each other. The thing that makes good packaging is veracity. Is it verified? So did you sign your package? Did you test it before you put it all together? Is it easy to do correctly? Is it simple? Is it hard to do correctly? Like, I don't know, Python packages tend to be. Is there one right way to do it? Again, Python. Is resolution capable? Can you make this package deal with other packages that it requires? And is it relatively self-contained, or did you need to install this particular package onto a particular machine that had a completely different set of packages that didn't have anything to do with this package? Like, for instance, if you had a, let's say, for instance, you had an executable .exe file for Windows. In order to run an exe file, under most circumstances, you need a Windows runtime, which means you have to have this other container. It's not really self-contained. Most things aren't. The Java jars aren't self-contained. They need a JVM to run them. But self-contained can be a much bigger problem to deal with. That's last on the list. So the question might be, what's this talk about again? So it's about packaging, to be honest with you. But it's about packaging everything, code and infrastructure code and data and documentation, and resolving those as a running system. Now, people that I work with think I'm crazy. They think that this is too hard. They think that this is not worth doing. I not so respectfully disagree. So our path in this is we do base image cadence. We build binaries based on some known set of code, updated for security purposes, updated for on a cadence. So we release these in a cadence. And then we layer additional stuff on top of them. And then we might deploy them, but we only deploy our stuff out of Nexus. If it isn't described in Nexus, it's not a thing to me. That's not a real thing. If I can't deploy my code out of Nexus, you have some toy code that does not fit within our system, and I don't really feel like talking to you, and I'm sure as heck not going to help you. Now, the key piece of this is that you can redeploy this stuff out of Nexus because, again, we do this out of releases, and what do we not do with releases? We don't ever get rid of them. Our promise to you is that we maintain accessibility. So in the future, I can deploy this software again, usually in a very, very equivalent format. Why do I keep talking about packaging? Well, all of our code produces packages. Right now, our code produces Java. We're a JVM shop primarily, and we produce jar files and tarballs for Python. Some of our packages are done with custom types that we built. We have a bunch of configuration management package types that run configuration management tools based on the contents of that. We do a bunch of testing based on the contents of configuration management. We do a bunch of imaging based on types that we built out of from Maven that generate outcomes that then allow us to make predictable results about what's going to happen. We also do it with data, but unfortunately, I'm not allowed to talk about how that works for a couple of reasons. Now, so we build this cadence, we layer everything into a maximally configured file system, and the deployments just involve injecting runtime configuration. We used to have this super long 29-minute process where we deployed our application. That's about 39 seconds now, I believe, at last guess. Because we bake all of this work at the beginning. We built an image. We tested that image. We decided it was okay. We already knew this. And everything about it lives in Nexus, so we already know where everything is. It just has a GAV that we just point at and go, there it is right there. That's the one we're going to deploy. It has a version chain of dependency described by that GAV and thus produces some relatively deterministic outcomes. But some of it is hard. So naming stuff is super hard. Doing names correctly are really hard. People have, the classic joke. There's two problems in computer science: cache invalidation, naming, and off by one errors. It is. Naming is super hard. Defining abstract packaging types that don't exist in the moment can be very hard. I had to define a packaging type for Packer images. And that turned out to be a really weird problem because the actual things themselves don't always live as binaries that you can access directly. Keeping it clean is hard because people have a strong tendency not to keep things clean. Developers always want to play with fun new toys. And it's like, this is just not a fun new toy. This is a thing that makes your work go smoother. Operators feel constrained to get stuff done. And so they're like, oh, this doesn't do exactly what I'm doing, so I'm just going to go around the process. This can be hard. And everybody has one of these. They got a manager who just woke up with a brilliant new idea that's going to revolutionize the world and makes everything that you've done so far really hard to do. The things that aren't hard. Managing Nexus is not hard. I mean, it's practically effort. I think we should probably spend 20 minutes a month, maybe, doing this, maybe. It turns into 30 if we have to do an update. Resolving the output, it's trivial. Executing the process itself, we have a bot for that. Auditing the outcomes, I mean, they're self-auditing for practical purposes. We have logs, and then we have the immutable source of those things. So what are we going to try next? First, we're going to try to open source some of these custom types. We'll see how that goes. My company's not really big on that right now, but I'm making some inroads in that. Anything I lied about just now, which I don't really mean to have, I'm going to try to fix that before I do that, obviously. We need to do secrets management because everybody knows that's hard. And we're going to try to do this. We're going to try to help other people understand how this process works at the very, very atomic level, which is sort of where we're working at it. We're not looking at it from the terms of like, hey, Jenkins can make magic happen. I don't give a crap about what Jenkins does. Jenkins' job entirely is to tell me whether the PR builder worked or not. Did you pass your PR? That's really what I use Jenkins for. I don't use it for anything else. So there is some reading you might want to do if you get this presentation. The Creativity Delusion is a series that you can really watch. It talks about how everything is really based on everything else. Read Mark Burgess's work. Read the plugin guide for the Maven release plugin. The Infrastructure as Code Wikipedia article, and especially Martin Fowler's work in that. And there's a Sonatype article that has some really terrible formatting about building customized artifacts in Maven that can help you move forward. Thanks for your time, and I will be in Slack if you have any questions.
Hey, Mykel, that was a great presentation. Stay with us for a couple of seconds here. So yeah, that was, you know, I always love hearing you present. One, because you're not afraid to tell it like it is. I think that you know, I took a lot of notes during that presentation, as I have been all morning. But I think the key thing that you really hit on here and continue to hit on is, you know, when people talk about, and you talked a lot about, here's how we do things and why we do things and what our process is and why it's a process and why we have promises in that process. And you tied it to this, you know, idea of there's a social construct here that we're forming. And that, you know, that concept really helped for me, and hopefully tied, you know, for other people here, this, you know, the relationship between the culture and the tools and the processes, right? This, you know, a lot of people talk about, let's automate, let's use this tool, let's do this, you know, because it's cool or whatever. But you're really, you know, when you're trying to do releases, when no human is touching these releases that you have, right? The social constructs and the promises are what you're setting up in that build process. And it is a social platform, if you will, or a social CI, you know, CD pipeline that you're building, that you're delivering upon. And I think that the way that you were able to match that in the beginning conversation of like, how do we set promises? How do we deal with relationships? Why are those important? Really came out. So you just did a bang up job here. I really appreciate that. I love learning from you and others like you in the community. So super job. You know, we'll be over in Slack I'll be over on my other computer here. But again, thank you for joining us.
Thank you.
Super talk. And I'm glad we had you on. We're going to take a lunch break. We will be on Slack, but we're going to take a lunch break in terms of the presentations. Jamie Whitehouse, who is the Nexus Lifecycle product owner, is up next. So I just saw him in the office here yesterday, but I think he's back home for his presentation. And then he's going to be followed by DJ Schleen from Aetna, who I've already seen is on Slack already, talking about their DevSecOps journey there. So be sure to join us in the Slack channel. We will post, or it's already posted, where you can join the next set of sessions. So we're going to be off this URL pretty soon and on to a new YouTube channel after lunch. We'll post that in the Slack channel as well for any of you looking for it. But thank you very much, and we'll see you again in just a couple minutes.